In this video, we will start with revision exercise 8 of algebra. You will find this on page 393 in the Namibian AS-Level Mathematics textbook Y equals mx+c to success. So in this video, we will first do part 1. And in part 1, I'm going to do 1, 2, 3, as well as 4. Again, you can stop the video, first try it on your own, and then as soon as you are finished, you can continue the video. Let's start. Number 1. It's absolute value, so it's 0.4x minus 0.8, and it's 2. Okay, so this is actually a very easy, very basic one. So it's 0.4x minus 0.8 is positive 2. You don't have to write the positive. Or 0.4, oh, it seems to me I forgot that x, sorry. Luckily I see it when I was rewriting it. Okay, x minus 0.8 is equal to negative 2. Okay, so it's 0.4x equals 2 plus 0.8. So 0.4x equals 2.8. If I divide by 0.4 and I divide by 0.4, I get that x is equal to 7. The same here, 0.4x equals negative 2 plus 0.8. So 0.4x equals negative 1.2. I divide by 0.4, I divide by 0.4, and x is equal to negative 3. You can test it, but most of the time when it's a constant, it's just working. But substitute therein if you want. You can even with just checking it. So it's 0.4 times that 7 minus 0.8, and that's just the 2. And the same here. If I press in 0.4 times negative 3 minus 0.8, and I'm getting, but remember, I get negative 2, but it's in the bar, so it becomes positive 2. So both is solutions of the equation. Okay, that's number 1. Number 2. Now, number 2, be careful. That's an inequality. And now it's an inequality on the right-hand side as well as on the left-hand side. Okay, so can you recall how we did that? Otherwise, just go back in the textbook. And I can tell you where in the textbook, because this is the way I want you to approach this. So if you cannot recall, then always first go in your textbook and first find that solving inequalities. It's there on page 377. So if you cannot recall, go to page 377. And first revise the algebraic method as well as by using a graph. So this is very important. So I'm starting, there's my inequality. And I have 3x minus 2. Now the algebraic method, if we don't draw a graph, is where we will go and we will square both sides. Okay. So in this case, we are, I just want to just make it another bracket. We will take this one and we square. And we take this one and we do exactly the same. We square. That's the method of algebra. Otherwise, I have to draw the graphs. In the next question, I will draw graphs and I'll show you how to draw graphs also. But in this case, it's x squared. And if I multiply, I think it's the best. We can just do that. Square the first one. So it's 9x squared. This is negative 6x. Times 2, so it's negative 12x plus 4. Okay, now I take everything to one side, so negative, so it's 8x squared minus 12x plus 4. Now, remember, this is chapter 1. This is a quadratic inequality. Now, can you remember how did we do quadratic? We were doing it, we can do it here on the side. We are first going to make it an equation just to find, to make a sketch. Okay, so now in this case, if we're going to factorize this, we can basically just go and we divide it by 4, divide by 4, divide by 4, divide by 4. So it's 2x squared minus 3x plus 1 And then it's going to be 2 and 1, and it's going to be 1 and 1. So it's group A. So 2 plus 1 is 3. The signs are the same, minus, minus. So if I put a x and x, I will get that it's 2x minus 1, x minus 1. So 2x equals 1, x equals 1. So x is a half, or x is equal to 1. Okay, but now if I make a small sketch, remember quadratic inequalities, go again to chapter 1. If you cannot recall it, I can just quickly check if I can see it fast on what page it is. I'm just checking. Quadratic inequalities, I even check in the index and I see it's on page 26. So if I go to page 26, I'm just going to double check for you. Okay. So I go to, and there, quadratic inequalities, page 26. So if you cannot recall, go to page 26 and first revise that. Okay, so there's a half, and there says 1. And now, because this was smaller, if you read from this side, but it still doesn't have, okay, I'm just looking for that. But if it's smaller, it means that this side, actually, let's rather make it red. This is highlighted. Do you see? So from the sketch, I can see that x is bigger, keep the same, it's not the equal, so bigger than a half, there, it's that part, and smaller than 1. Now, how can I test to see both sides work? I will substitute. So can I just do actually it's good to do first the check, and then just to put in. Okay, now if I check and I put in that values, okay, so let's put in the half, and then we are going to just to see if both sides is working. Okay, so this is going to be a half, and this is going to be 3 over 2 minus 2. Okay, this is in the bars. So this is going to be a half. And if I'm going to say 1.5, so it's going to be negative a half, but that half is going to be a half. So yeah, that is a solution. The same is if I now substitute the 1. I'm just going to do it here to show you. Instead, I will now just put a 1 there. This I can clean. Okay, so check your two sides to see both is working, if it was in an equation. Okay, so if it's 1, 1, so this is 1, it's fine, and this is going to be 3, and this is also 1, so 1 is equal to 1. So, therefore, my solution will be x is bigger than a half and smaller to 1, exactly as it stood there. Okay, so that was solving the inequality. Otherwise, you had to draw, not this was just quadratic inequalities. Otherwise, you have to draw the graph y equals x, the graph y equals 3x minus 2, and then see where is this graph, the first graph on top of this graph. But go to page 377 and revise it if you cannot recall it. Okay, let's make space for the last two in this video. Okay, let's just go. Okay, so the next one, number 3, by sketching a suitable pair of graphs, show that the equation, and this is 3x, and this is 16 minus x to the power of 4, has two real roots. So y is equal to 3x, y is equal to 16 minus x 4. Okay, now the best will be, they say by sketching, so they want the sketches. So the best will be to use a graph. So let's just use a graph. We start with very basic and see if we must make it a little bit longer. Okay, so I'm going to use a table. I think the best will be a table. Now, this one is actually not so. That one can become a little bit big with a table, but still, and we can always extend the table if we see it's still not intersecting. Okay. So if I use a table and I start with the first one, then this is x and this is y. Okay. Now, let's start with -3. So if it's -3, it's going to be -9, but due to the absolute value, it's just going to be 9. Okay. And then if it's -2, then it's going to be -6, but it's going to become 6. And then it's -1, so it's going to become 3. And then it's 0, 0. Okay, now I made it a bit long. So 1. Okay, let's just go a little bit. As I said, you can extend it or make it shorter. So in this case, if I put 1, so this is going to be 3, 2, 6, and 3, 9. Okay, do exactly the same. Remember, I will substitute it like this. I will say 16 minus, okay. If I'm going to, this is going to be very big, but let's put the -3. So 16, so it's going to be -3, but it's to the power of 4. So it's 16 minus, and if you go 3 to the power of 4, remember that negative becomes a positive, okay? But due to, so it's positive, inside positive 81. So 16 minus 81, and that's -65. And then if you put -2, and now you can just use your calculator. Say 16 minus bracket, -2, close the bracket, to the power 4 equals, and I'm getting 0. And then if I put -1, so remember this will just be 16, this is going to become positive, so 16 minus 1, and that's going to be 15. And if I put 0, so 16 minus 0, so that's going to be 0, 16. And then 1, you can continue, but it's going to be, that's nice because it's repeating, and then 2, 0. But again, just press it in your calculator. I'll do the last one, the 3 for you. I'll press it in. So press 16 minus, okay, bracket. And then now it's just positive, so it's 3, okay, you can even close the bracket, to the power 4 equals, was not even necessary for that bracket. Okay, so this one can be a bit extreme, but let's see what we can do to see how we're going to sketch. Now, remember what I always said, you must use a ruler and make 1 centimeter blocks. I just use a grid, okay. So the first thing is make your table. Now that part is going to be relative in the middle, okay, and first please get your ruler. So let me just get my ruler. Okay, and let's see what we can do from here. Okay, and then you're going to have, in this case, okay, let's just see if I can go 1, 2, yes, let's go in 2 blocks. Think it will work because that's not so wide. Although then you can just make it 2 centimeter spaces. Here we will think now, because the extreme, if you look at the y, that's only up to 9, but the problem, there's a 15, do you see? And the -65. So that's going to be a bit more challenging. So we can make it 10, but then it's going to be 10, 20, but then this is -10, -20. Then we will go very low, -30, -40, unless we leave out the 65s, which will also work. But let's see if it's working. So as you go, you will just see, you have to go up to here. You see what I mean? To get that -65 in. 60, -70. Okay. Okay, and now I plot the points. So -3, okay, let's just go. -1, -2, -3. 1, 2, 3. So -3 is 9. Okay, so now due to the scale, this one is very close. So -2 is 6. Just a little bit. So -1 is 3, so it's going closer. And then 0, 0. and the same 1. So 1, it's 3. 2, it's 6, a little bit higher than the middle. And 3 is 9. So due to my scale, this one is actually going to be, just use your ruler there. And remember to name it. So y is equal to 3x. Okay, now let's do the other one. So if it's negative 3, then now this one is nice if we can do it up to negative 65. So negative 2 is 0. And negative 1 is 15 in the middle. And 0 is a little bit higher. Oh, it's maybe too high there. And then the same 1 is 15. And 2 is 0. And 3 is negative. Oh, let's just move this. 3 is negative 65. Okay. And then if I take a freehand, remember, the other one is with a ruler. This is a curve. Okay. Oh, no, that one, it didn't go through the 2. Okay, I think this is a little bit better. Okay, and then this graph is y is equal, and that was the 16 minus x to the power of 4. And now what was the question? The question was not just to sketch. The question was, by sketching, show that the equation has 2 real roots. Okay, so you're going to say, therefore, okay, 2 points. Do you see the 2 points of intersection? You can say 2 points of intersection. So the graph has the graphs have 2 real roots. Can I just, now that I'm checking my answer, I think I could have left this part. Did you see? Because then I could have made the scale and I would have found my 2 points of intersection. So going a little bit of rethinking, I think maybe yes, I think it would have been, because then I would have just be highlighted on this part, which would have been enough. But it will not have an influence. It's a sketch. Okay. Okay, let's do the last one in this video. So that's how you do it. Let's just get rid of our grid. Let's just go normal again. Let's just take it up. Let's just clean it here. Okay, let's just take that away. Let's just do this. And now we go for number 4. Move it down, move it up. Get the line away. Number 4. Okay, let's start with number 4. So let's first read number 4. What is number 4 saying? Solve the equation. Now, this is not the inequality, it's just an equation. So how can I do this one? So let's just see. If I'm having 3u plus 1, and that's 2u minus 5. How do I solve this? So this is very easy. I can just say 3u plus 1, and I take the positive option, 2u minus 5, or it's 3u plus 1, and I take the negative option, 2u minus 5. Then it's 3u minus 2u equals negative 5 minus 1, and that's u is equal to negative 6. Or you can say 3u plus 1 equals negative 2 plus 5. So 3u plus 2u is equal to 5 minus 1. So 5u is equal to 4. So therefore u is equal to 4 over 5. I can test to see that both. So check. Let's just do the check. So if I'm putting the 3 and I put the negative 6 plus 1, always remember to do the check, especially if there's an absolute value on that side also. So 2, and then it's negative 6 minus 5. Okay, so this is going to be negative 18. So it's going to be negative 17. And this is going to be negative 12, so it's also going to be negative 17, but at the end 17 equals 17, so yes. And then I'm always doing it like this. You do exactly the same, but now you just substitute, and let's just clean this because the answer will be different here. And then I'm putting the 4 over 5 and the 4 over 5. Okay, and if I simplify this, I'm getting 3 and 2 over 5. And I'm getting negative 3 and 2 over 5. So it's 3 and 2 over 5 equals 3 and 2 over 5. So because the absolute value of a negative is a positive. So I can end by saying, therefore, u is equal to negative 6, or u is equal, or you can say both is solutions. Both are solutions. Okay. But now number B. Okay, so I'm just going to clean my check because I just want to have a little bit more space. I'd leave the answer. I'm going to use the answer. Because as soon as they use the word hence, it means, and I said it, the answer of A must help you in B. So hence solve the equation. Now you have to compare. If I'm writing it down, start comparing. Okay. It's going to be 3 cot x plus 1. And it's going to be 2 cot x minus 5. Okay. Now, if you compare it, take note, 3, 1, 3, 1, 2, 2, negative 5. So, from A, you can say, from A, you can see, okay, and now I'm writing it down. I just want to use u is equal to, and now I'm just going to say u is equal to cot x. Now both is solutions, so therefore, okay, but very important. This is very, very important, that interval. And if you think of that interval, if you think of a cos diagram, there's pi over 2, there's 3 over 2 pi, and there's 2 pi again. So from this, you can see it's only in quadrant 1. Keep it in mind. Okay, because now I'm going to substitute the u's. I'm going to say negative 6 equals cot x. I have to swap it actually around. I think it's better, and in this one I'm going to swap it around. I want to say cot x is negative 6, or cot x is 4 over 5. Okay, I don't work with cot, I work with tan. So go tan x is negative 1 over 6, or tan x is 5 over 4. Now, from the cos diagram, you can see it's only in quadrant 1. So this negative option will be out. You can say reject, not in interval. So I'm just going to work with this one. So if I have my, okay, and again, there is my cos, and it's in there, and there, it's going to be, okay, let's just take another color, there. So I first get my basic angle. Remember, I'm in radians. Put your calculator on radians. So press shift, and then press tan, and then press bracket, 5 divided 4, close the bracket, and then make it at least 4 significant figures. So 8, 9, 6, 1. That is that angle. But if you want to find, so therefore, and continue, x is it's in quadrant 1. So 0, make it to 3 significant figures. 0.896. Okay, I'm just saying it incorrect. So therefore, the answer is x equals 0.896. Okay, because I reject this one, I'm only up to pi over 2. That's how you do it.